Cumulative frequency in grouped data. Welcome, everyone. To begin our lesson today, let's take a moment to reflect on what we have already covered. In our previous sessions, we focused on finding the median for ungrouped data, where we could simply list out our numbers and pick the middle value. However, as we move into more advanced statistics, we have to consider real-world scenarios. In the real world, data is often far too vast to list out individually. To make this information manageable, we organize it into what we call class intervals, for example, 0 to 10 or 10 to 20. When we organize data this way, we refer to it as grouped data. Now, because the individual values are hidden within these intervals, we can no longer find the median by simply counting observations one by one. Instead, we need a more specialized tool to help us track our progress through the data. That tool, which we will be exploring in detail throughout this presentation, is called cumulative frequency. Understanding the concept. Now that we've established that we use grouped data when dealing with large datasets, let's dive into the core concept of this lesson, understanding the concept of cumulative frequency. First, you can think of cumulative frequency, or CF, simply as a running total of frequencies. Just like when you keep a running tally of points in a game, you are constantly adding the new values to the ones you already have. To be more precise in the context of our grouped data, the cumulative frequency of a specific class interval tells us the total number of observations that fall below the upper limit of that particular class. This is a crucial detail to remember for later when we identify the median. If you're finding the term a bit technical, just think of it as a cumulative sum. It is a cumulative process where each step builds upon the previous one. To make this concrete, let's look at how the math works. If you are looking at the cumulative frequency of the second class interval, you aren't just looking at that group alone. You are adding the frequency of the first class and the frequency of the second class together. We will see this exact addition process in action in just a few slides when we walk through a numerical example. The less than perspective. Now that we understand that cumulative frequency is a running total, let's look at a very important way to interpret these numbers. You can think of cumulative frequency, essentially, as a less than distribution. To make this clearer, let's look at this example. Suppose we have a class interval of 10 to 20, and we find that its cumulative frequency is 25. What does that actually tell us? It tells us that there are 25 observations that are less than 20. In other words, all the data points from the previous groups, plus the ones in this current group, combined, total 25 values that fall below that upper limit of 20. Keeping this less than perspective in mind will be crucial when we start calculating the actual values in the next few slides. How to calculate cumulative frequency, step by step. Now that we understand the concept of cumulative frequency as a running total, let's look at the practical side. On this slide, I will walk you through the step-by-step process of how to actually calculate these values for a grouped frequency distribution. First, step 1. You always begin with the very first class interval. Since there are no previous groups to add, the cumulative frequency for this first class is simply equal to its original frequency. Moving on to step 2. To find the cumulative frequency for the second class, you take the frequency of this second class and add it to the cumulative frequency we just found for the first class. Next, step 3, the pattern continues. To find the cumulative frequency for the third class, you take the frequency of the third class and add it to the cumulative frequency of the second class. Finally, step 4, you simply repeat this additive process for all the remaining classes in your table. You keep adding the next frequency to your running total until you reach the very end. A great way to check if you've done this correctly is to ensure that your final cumulative frequency is exactly equal to n, which represents the total number of observations in your entire dataset. In the next few slides, we are going to put this exact method into practice using a real-world example of student test marks. Real-world example. Now that we understand the theory behind cumulative frequency, let's put it into practice with a real-world scenario. Imagine a teacher has just finished grading a mathematics class test and has recorded the marks for 50 students. Because there are so many individual scores, the teacher has organized them into class intervals to make the data more manageable. Our goal now is to take this frequency distribution and calculate the cumulative frequency for each of these groups, step by step, to see how the totals build up. Frequency table. Now that we understand the theory behind cumulative frequency, let's look at the actual data we'll be working with. On this slide, we have a frequency distribution table representing the marks obtained by 50 students in a math test. If you look at the first column, labeled Marks, you'll see our class intervals. These are our groups, ranging from 0 to 10, then 10 to 20, and so on, all the way up to the final group of 40 to 50. The second column, labeled Number of Students or Frequency F, tells us how many students fall into each specific group. For instance, in the first group from 0 to 10, we have 5 students. In the next group from 10 to 20, the frequency increases to 12 students. As we move down, we see 20 students scored between 20 and 30, 8 students scored between 30 and 40, and finally, 5 students scored in the 40 to 50 range. Keep this table in mind, because in the very next slide, we are going to use these individual frequencies to perform the step-by-step calculation to build our cumulative frequency column. Step-by-step calculation of cumulative frequency, CF. First, let's look at the first class interval, which is 0 to 10. Since there are no previous classes to account for, the cumulative frequency is simply the same as its frequency, which is 5. So, our cumulative frequency starts at 5. Moving on to the second class, 10 to 20, we take that previous cumulative frequency of 5 and add the frequency of this current class, which is 12. When we add 5 plus 12, we get 17. Next, for the third class, 20 to 30, we repeat the process. We take our running total of 17 and add the frequency of this class, which is 20. This brings our cumulative frequency up to 37. Now, for the fourth class, 30 to 40, we take our current total of 37 and add the frequency of 8. This gives us a cumulative frequency of 45. Finally, for the fifth and last class, 40 to 50, we add its frequency of 5 to our previous total of 45. This brings us to a final cumulative frequency of 50. Now that we have our frequency table from the previous slide, let's walk through the actual calculation step by step so you can see how the cumulative frequency builds up. As you can see, the numbers are steadily accumulating. In the next slide, we will look at the completed table to verify that our final total matches the total number of students we started with. Final cumulative frequency table. Now let's bring everything together. After following those step-by-step calculations we just walked through, we can present our results in this final, completed cumulative frequency table. Take a look at the columns. On the far left, we have our marks, organized into their class intervals. In the middle column, we have the frequency, which we'll call lowercase f, representing the number of students in each specific group. And finally, on the right, we have our cumulative frequency, which we'll call capital F, representing our running total. Looking at the first row, for the 0 to 10 marks interval, the frequency is 5, so our cumulative frequency starts at 5. Moving to the second row, for the 10 to 20 interval, we add the 12 students in this group to our previous total, giving us a cumulative frequency of 17. In the third row, for the 20 to 30 interval, we add the 20 students in this group to our running total of 17, which brings us up to 37. For the fourth row, the 30 to 40 interval, we add the 8 students to our previous total, reaching 45. And finally, for the fifth row, the 40 to 50 interval, we add the last 5 students, which brings our final cumulative frequency to exactly 50. Notice how this final number, 50, matches our total number of observations, which we'll call lowercase, and this is a great way to double-check that our calculations are correct before we move on to the next slide, where I'll show you how to use this specific column to actually locate the median class. Why is this important for the median? As you remember from our earlier lessons on ungrouped data, finding the median is quite straightforward. You simply locate the middle value in your ordered list. However, as we saw in the previous slides, when we deal with grouped data, we run into a bit of a challenge. We no longer have access to the exact, individual values of every single observation. All we know is the range, or the interval, that they fall into. This is exactly where our cumulative frequency becomes the hero of the story. It provides us with the tool needed to identify what we call the median class. To do this, we use a simple method. First, we take the total number of observations, which we call n, and calculate n divided by 2. This value tells us the position of the middlemost observation. Once we have that number, we simply scan down our cumulative frequency column to find which class interval contains that specific observation. Let's look back at the example we just worked through. Our total number of students, or n, was 50. So we calculate 50 divided by 2, which gives us 25. Now, let's look at our CF column from the previous slide. We can see that the cumulative frequency jumps from 17 to 37. Since our target number, 25, falls right in that jump, we know that the 25th observation must be located within the 20 to 30 marks class interval. This class is our median class. Now that we have successfully calculated our cumulative frequency table, you might be wondering, why did we go through all this extra work? How does this help us find the median? In the next slide, I will highlight some common pitfalls to watch out for so you don't make mistakes when performing this calculation yourself. Common mistakes to avoid. First, a very common mistake is confusing the frequency, which we denote as lowercase f, with the cumulative frequency, which we call capital CF when you are trying to locate the median class. Like we discussed in the previous slide, you must use the cumulative frequency. Remember the distinction. Lowercase f represents only the number of observations within that specific group, whereas capital CF represents the running total of all observations up to and including that group. Second, be extremely careful with your arithmetic. Because cumulative frequency is a running total, a single addition error in the second or third row will create a domino effect, making every subsequent cumulative frequency incorrect for the rest of your table. I strongly recommend you double-check your additions as you go. Finally, watch out for misinterpreting the upper limit. It is easy to get confused about which boundary we are talking about. Always remember that if you see a cumulative frequency of 17 for the class interval of 10 to 20, this means there are 17 values that are less than 20, not less than 10. Now, before we wrap up today's lesson, I want to pause and discuss some common pitfalls. Even if you understand the concept, it is very easy to make small errors that can lead to the wrong answer. Keep these points in mind, and you will be well on your way to mastering grouped data. Key takeaways. First, remember that cumulative frequency is simply the running total. It is the sum of the frequency of a specific class and the frequencies of all the classes that came before it. Second, it is crucial to remember the perspective we discussed earlier. The cumulative frequency represents the total number of observations that fall below the upper limit of a given class. Third, a great way to check your work is to look at your final result. The final cumulative frequency must always be equal to the total number of observations, which we denote as n. If your final number doesn't match your total sample size, you'll know there was a calculation error somewhere in your steps. Finally, keep in mind that mastering this calculation is a vital prerequisite. You cannot identify the median class in group data without first being able to accurately determine these cumulative totals. To wrap up our lesson today, let's quickly recap the key takeaways to ensure you have a solid grasp of this concept. Now, as long as you keep these points in mind, you'll be well prepared for more advanced problems involving frequency distributions. Great job today!